Here's the answer to number 2, that if you wanted to saturate 100 grams of water at 90 degrees, it would take 40 grams of NaCl. I went to the 90 degrees, I went up to the sodium chloride curve, which is this one, and then I went to the left to see that it'll take 40 grams to saturate 100 grams of water at 90 degrees. For the KNO3 potassium nitrate, that's this curve right here, at 15 degrees, if I go to the KNO3 curve, I land here, and if I go to the left, it's approximately 28 grams, give or take. That'll saturate 100 grams of water at 15 degrees Celsius. So for number 5, we are going to need a proportion because we are dealing with not 100 grams of water, but 300 grams of water. Remember, the graph tells us how much is in 100 grams of water. So we're going to have to do a proportion, and the question is, in 100 grams of water, how much is going to make it saturated? Got to use the graph to figure that out. And then we'll scale it up, how much in 300 grams of water, which is how much the question asked for. So I'm going to go to 40 degrees Celsius, and I'm going to look up potassium nitrate. So 40 degrees, potassium nitrate is this curve, that's about right there. And then if I go to the left, it's approximately 62. So we'll just call it 62 grams, would saturate 100 grams of water. And so then the question is, well, how much does it take to saturate 300 grams? And so this is a cross multiplication. We'll just do 100x equals 62 times 300, and to solve for x we have to divide by 100. So that gives us x is equal to 62 times 300 divided by 100, 186. So the answer is it would take 186 grams of potassium nitrate to saturate 300 grams of water at 40 degrees Celsius is what we have determined. Number 9, is this saturated, unsaturated, or supersaturated? It's in 100 grams of water, which is what our graph is in. So I just need to plot the point of 230 grams and 60 degrees. So here's 60 degrees, here is 230 grams. And you'll notice, and then we're looking at potassium iodide, which is this curve. And since my point is right on the line, that makes this a saturated solution. And finally, comparing levels of solubility, we established that because sodium chloride had very little change from 20 to 100 degrees, that has the least change in solubility. And then if you look at from 60 to 90 or 30 to 60, it doesn't matter. You'll notice potassium nitrate has the greatest change from the lower temperature to the higher temperature. You can dissolve way more when you increase the temperature, as opposed to sodium chloride, where you can dissolve marginally more with an increased temperature.